In this lecture, I'm going to show you how to find the direction of frictional force in a case of rolling motion. That is, when a body is rolling, we can't find out the direction of frictional force by direct observation. For that purpose, I'm considering a general case which is applicable to all possible cases depending on the uh, case that is given. Okay, for this purpose, what I'm doing is I'm considering a rough horizontal surface. The surface under consideration here is it is rough. On this rough horizontal surface, I'm considering a body which is capable of rolling. So I said a body which can roll because it is applicable for a disc, for a sphere, or for a ring, anything. It can be applicable for any object. So for that purpose, let me assume mass of this body which can roll is capital M, I am taking it as, and its radius I am taking it as capital R, and coefficient of friction that I am considering here is mu between the surface and the body. Now I am considering a general case in which the line of action of the applied force passes through a point which is at a distance small r from the center of this rolling body. Okay, so for this purpose, first let us consider what are the different forces acting on the body. So if you take this as the disc, okay, so on this disc applied force F is acting towards the right direction. What is about the direction of frictional force? See, as long as we don't substitute the magnitude of a frictional force as F is equal to mu into N or any other value, okay, in rolling motion you can consider any arbitrary direction for friction. That is, here the possible directions are either it should be to the backward direction or to the right direction. It can be anything, but for generality's sake I am assuming here that it is backward direction. I'm assuming that the frictional force is acting backward direction. This is my assumed direction. I'm not pretty sure whether it is back or front direction, because of which I'm taking an arbitrary direction as backward direction. So by taking this, I'm proceeding, and let me check whether my assumed direction is correct or not, depending on the given situation. Okay, so as the body is moving to the right direction with an acceleration a, where ac is the acceleration of center of mass, what I can write, force to the right direction, resultant force is F minus frictional force should be equal to m into acceleration of center of mass. This is equation number 1. Next I am talking about torque. So to find out the torque, I am using this expression, because when a body is undergoing pure rolling motion, the point at which the body is in contact with the floor, that is point P, can be considered as instantaneous center of rotation. So I am writing down the torque equation about point P, that is the point of contact, is given by, with respect to P. Why I considered here with respect to P? Because here the torque due to frictional force is 0. Directly I can write down the torque due to applied force only. So the distance, perpendicular distance between this point and the line of action of applied force, perpendicular distance from here to here is capital R, this is small r. Total distance is capital R plus small r into the applied force F is equal to IP, moment of inertia about P into alpha, where alpha is angular acceleration. What is IP? Simply apply parallel axis theory. What is IP? You can write it as IP is I center of mass, IC, plus M into square of the separation between these two. Square of the separation between the center of mass and this point P. That is how much? M into R square into alpha. Okay, through this, that implies alpha is equal to what I can write? Alpha is equal to, so send everything to right direction. What you will be getting? F into capital R plus small r divided by, if it comes to right, it will go to denominator, because of which I can write it as IC plus capital M into R small m, as I assumed it as small m, into capital R square. This is the value of alpha. As I assumed that the body is undergoing pure rolling motion, what is the condition for rolling motion? Rolling motion, acceleration of center of mass, AC, should be equal to R into alpha. Okay, if we substitute this into this expression, we will be getting the expression for acceleration of center of mass as AC is equal to R alpha. R into alpha is how much? F into capital R plus small r divided by IC plus M into capital R square. So from this expression, I calculated acceleration of center of mass. Now, how to find out the direction of frictional force? For that purpose, what I am using is, I am going back to this expression number 1. Therefore, frictional force acting on the body, F is equal to what I can write? F minus M into AC. That is equal to, what is applied force is F only, minus M into, what is acceleration of center of mass? R F into capital R plus small r divided by IC plus small m into r square. If we take the LCM and cancel out the terms, whichever cancelling out, what you will be getting? If you take F common, okay, what you will be getting? Small m into r square, capital R square. Small m into capital R square gets cancelled. Okay, so only thing that is retained over here is IC minus second term only. What is that? Small m into capital R into small r divided by IC plus m into r square. This is the expression for the frictional force acting on the body. So, depending on whether this line of action is passing above the center of mass or below the center of mass, through the center of mass, the direction of frictional force will change like this. For this purpose, first thing that I am going to consider here is case number 1. First case that I am considering here is, what if the line of action of applied force is passing through the center of mass? That is characterized by, what if R is equal to 0? R is equal to 0 means the line of action of applied force passes through the center of mass. In that case, what is the direction of frictional force? So for that purpose, again I will go back to the expression for frictional force acting on the body. F is equal to capital F into IC, okay, minus, in this what you should substitute? Small r is equal to 0. When you substitute small r is equal to 0, this whole term will become 0 only. F into IC divided by IC plus m into r square. Have a look at it. Applied force to the right, which is positive, and IC is m into r square, always it is positive. All the parameters are positive, because of which here the frictional force is positive. Positive frictional force means the direction of frictional force which I assumed and the actual direction of frictional force when the line of action of applied force passes through the center of mass is same. So from this we can make a concrete statement like this. What is that? When the applied force passes through, the line of action of applied force passes through the center of mass, the frictional force acts on the body in which direction? Opposite to the direction of acceleration of center of mass. That is opposite to the direction of applied force. This is observation number 1. So in the case of line of action passing through the center of mass, what happens? The body will undergo both translatory motion and rotatory motion, but the frictional force acting on the body will be in backward direction. That means frictional force is back or opposite to the direction of applied force. Okay, this is a concrete statement that we can keep in mind. It is independent of the shape of the body, whether it is a circle or disc or sphere, whatever it may be. When the line of action passes through the center of mass, the frictional force acts opposite to the applied force. That is observation number 1. And the torque due to applied force is 0. Only torque is due to the frictional force. So because of which, in this case, body rotates in which sense? In, and rotates in clockwise sense. because the frictional force is acting backwards and line of action of friction applied force is passing through the center of mass. Friction due to applied force is 0, and only force which is producing torque is the frictional force, and which is producing torque in clockwise sense, because of which body has a tendency to rotate in clockwise sense. This is observation number 1. Now I'm going to consider case number 2, in which the line of action of applied force passes through a point which is below the center of mass. It is characterized by, what if r is negative? So that I am showing here diagrammatically like this. This is the body. So this is the center of mass or center of the body, and the line of action is below this. Okay, in this case, what is the direction of frictional force? Okay, my assumed direction of friction is backwards. This is assumed direction. I'm not sure whether actual direction of friction is back or forward. So what if r is negative? That is, the line of action of applied force is below the center of mass at a distance r from the center of mass. In such a case, again I am going back to this expression. What is the expression? F is equal to frictional force acting on the body is equal to F into IC. Okay, when r is negative, you should substitute r with a negative sign. Minus into minus, it will become plus. M into capital R into small r divided by IC plus mr square. So if you look at here, so this whole thing is positive, everything is positive, because of which F is positive. F is positive. When F is positive, the direction of frictional force acting on the body is consistent with my assumed direction, because of which in this case frictional force is back or opposite to the direction of applied force. Okay, so as the frictional force is backward direction, what is the sense of rotation? What is the direction in which it rotates? So if you consider this point, about this point, the torque due to applied force will cause the body to rotate in which sense? Counterclockwise sense, because of which body rotates in which sense? Counterclockwise sense, C clock. So in this case, body rotates in counterclockwise sense. This is the case when the applied force is below, when the line of action of applied force passes through a point which is lying below the center of mass of the body. Now I am considering the case number 3, third case. In this third case, what I am assuming is the line of action of applied force is above the center of mass. That is characterized by, what if r is positive? So for that purpose, again I am drawing the diagram here. So this is the center of mass. See, above this at a distance, let me call it as a small r, the line of action of applied force is passing. This is the assumed direction of frictional force. I assumed the frictional force in backward direction. I wanted to find out what actually is the direction of frictional force in this case. Okay, so for that purpose, again I am going back to this expression. What is the expression for frictional force that we got? Frictional force F is equal to applied force into IC minus M capital R small r divided by IC plus M into R square. So when R is positive, what happens? The fate of the frictional force, that is the direction of frictional force, is decided by relative values of IC and this small m into capital R into small r. So in this I am considering 3 subcases. Case number A, in which IC minus m into capital R small r is greater than 0. That is, it is positive. So that is possible only when IC is greater than m into capital R into small r. That is possible IC divided by m into capital R is greater than small r. In this case, what happens? It is positive. When this term is positive, everything on the right side is positive, because of which the frictional force is consistent with my assumed direction, because of which I can conclude that frictional force is backward, acting in backward direction or opposite to the direction of applied force. And what is the sense of rotation? In which sense it will rotate? Will it rotate in clockwise or counterclockwise? Again, you consider with respect to this point, the torque due to applied force will make the body to rotate in clockwise sense, because of which body rotates in clockwise sense. And case number B, subcase number B, what if IC minus m into capital R into small r is less than 0? That is possible when IC is less than IC divided by m into capital R is less than small r. Okay, in that case what happens? Because this is less than 0 means it is negative. F is anyhow right direction, which is positive. Positive into negative is negative. That is F is negative. So negative means it is opposite to the assumed direction of friction. Assumed direction is back and it is becoming negative means it should flip to right direction. So in this case, the frictional force is in which direction? Is in forward direction. That is in the direction of applied force. Okay, and what is the sense of rotation in which it rotates? In this case also, if you consider with respect to this point, the torque acting is due to only the applied force only, because of which body rotates in which sense? Clockwise sense only. And I'm going for the third case and last case, that is C, in which IC minus m into capital R into small r is equal to 0. That is R is equal to, what I can write? IC divided by m into capital R. In this case, when this term is 0, altogether frictional force also is 0. Frictional force acting on the body is 0. That is, though the surface under which the body is rolling is having some friction, in that case where R is equal IC divided by m into R, the frictional force acting on the body is 0. No frictional force acts on the body. And what is the sense of rotation here? When the frictional force is 0, okay, the torque is due to applied force only, which is in clockwise sense. So body has a tendency to rotate in clockwise sense only. So depending on the line of action of the applied force, what's happening? The direction of frictional force is changing, and at the same time the sense of rotation also changes. This is how we can decide the direction of frictional force in a case of a rolling body.